Hello everybody, this is Sandesh Chand and this video is on searching of an element in an array. So just to recall, what do you mean by an array? An array is used to store the collection of variables of the same data types. As shown in the example, we can have an array of an integer, an array of a balance, and an array of a character. So what was the need of an array? An array was needed so that in the same variables we can save multiple values for our use. So one of the most important operations that we can do on an array is searching of an element. An array is needed to save multiple values in the same variable name. This helps us in storing the variables and thus preventing the use of extra memory required for the program. As we have already seen an example for 10 students and their marks for calculating the percentage and the average. Now consider that if I want to find the marks and the percentage for the student Sandesh in the list, or mark for the student with roll number 10 in the list, then what we need to do? First we need to find whether the roll number 10 exists in our list, and if it is present, then show the percentage, marks and average of that students. Otherwise, we need to throw an error. One of the strategy for finding an element in an array is called as linear search. A linear search algorithm is an iterative process that tests one entry of an array at a time. It means that it will compare the key value that we need to search and the element present in an array one by one. In this case, we start at the beginning of an array and compare every item in an array against the item we are searching for. The process stops once the item we are looking for has been found, or all the array items have been tested and match could not be found. We will check all the elements in an array. If an element is found in one of the locations, then our search is successful, otherwise our search is unsuccessful. The worst case scenario for this algorithm is not finding a match record. In this case, it is necessary to step through the entire array and match against every single item. So, if we have 124 items in an array, then we need to test all those 1024 items to confirm that match has not been found. Now we will see an animation which is adapted from the book Data Structures Through C. Here you can see that we are having an array of 10 elements. These elements are in a sorted order. It is not necessary in a linear search that all the elements should be sorted. We can use any type of array and we need only the key value that needs to be searched. So if we can see list A in which the data is to be searched. Suppose that the data is to be searched is 57. Then what we will do is we will check and compare whether A of 0 with 57. Now what is the value of A of 0? A of 0 value is 1. And the data is not found as A of 0 is 1. Then what we will do is we will move on to the next element, that is A of 1, and we will compare it with 57. Now the value of A of 1 is 2, which is not equals to 57. Hence we will move on to the next element, and the next element is we will compare A of 2 with 57. Now again we can see that A of 2 is 3, which is not 57, hence data not found. Again we will move on to A of 4. Now you just see and compare what is really happening. Now we have reached element number 8 and the searching is successful because the value at A of 8 is 57. So this is necessary that the key value should match with the value in an array. Here we can see that the value of a of 8 was 57 and the value of our key value was 57. Yeah, as both of them match with each other, what we can conclude is that if both the elements are same, our search has been successful. Now we will see the implementation of a linear search function in C language. I have created a function, a linear, with some variables declared. Now what will be my strategy first? First strategy will be that I will ask him or ask the user to enter the values in an array. So for that I will ask him that how many numbers he want to enter. I will take that value, consider it to be 5. Then I will ask him to enter the 5 values, and for that I use this for loop which says that for I equals to 0, I less than 5, I plus plus. As it is starting with 0, then the number of elements are 5, so 0, 1, 2, 3 and 4. And in this way what we can do is we can enter an element into an array. Now our main aim was to search an element in an array. So I will ask him enter the number which you want to search, and I will scan that value. Now in this for loop what we will do is we will compare the elements one by one. For this purpose we have used a for loop which will start with 0 and will go up to n minus 1. That is, for 10 elements we will go from 0 to 9, that is 10 elements. And what we will do is we will compare our key value. Here I have written it as m, whether it is equals to a of I, that is 57 equals to a of 0. Now we have seen that it was not the case, but if it was the case, then what would happen? I will make j to be plus plus, and the number is found at location m plus plus I. Now why I use that plus plus I over here? Because our array starts with 0, but for the user the number is at location 1. That is, if the element in an array that has been found is at location 0, for the user it will be at location 1. Hence what I have done is I have done it as plus plus I. Okay, now we will go from 0 to n. But if the j value never becomes 0, what does it mean? It means that the number was never found. So talking about the efficiency of a linear search, the first is it is easy to understand, easy to implement, and does not require the array to be in order. That is, it doesn't require the array to be in sorted order. But the main disadvantage is its inefficiency. So consider that if there are 20,000 items in an array, and what do you looking for is in the location 19,919th element, you will need to search throughout the entire list. So this will take your time, and hence it is less efficient. Linear search work well, but when used on an array with a large number of elements, they potentially have to check every element to find a match. This can take a while, especially if we are doing multiple such searches. There is no way to speed things up substantially, however, provided that the elements in the element are order. So a binary search looks for an item in a list using a divide and conquer strategy. Divide and conquer means that we will divide an array into an equal number of parts, and we will search for an element into that different part. So one of the main important thing to implement a binary search is that the array must be in a sorted order. The sorted order means that it can be in ascending order or it can be in descending order. So the algorithms begins at the middle of an array in a binary search. If the item for which we are searching is less than the item in the middle, we know that the item won't be in the second half of an array. Once again, we examine the middle element. The process continues with each comparison cutting in half the portion of the array where the attempt or where the item might be. A binary search works on an ordered list and first compares the key with the element in the middle of an array. In case of an even number of elements in our list, we will use the elements that ends the first half of our list as our middle element. So what is the strategy we will use? Binary search is for sorted arrays. We will compare the middle element with the key. If equal, match found. If not, if key is less than middle, we will look into the first half of an array. If key is greater than middle, we will look into the second half of an array, and we will continuously repeat these steps as and when required. This searching algorithm is very fast, at most n steps, where 2 to the power n is greater than the number of elements. So for a 30 element array, it will take at most 5 steps. Now we will see an animation for implementation of a binary search. Suppose that item to be searched is 57. The upper and the lower bound is called as mean and max respectively. So first we will need to find the middle. So to calculate the mid, the index of variable with which 57 is to be compared. So the formula is mid equals to mean plus max divided by 2, that is 0 plus 9 divided by 2, that is 4. Now we will compare a of mid with 57. These values are not equal. As 11 is less than 57, lower bound mid is now pointed to the next of mid, that is a of 5. Again mid is calculated. Now it will be 5 plus 9 divided by 2, and this value will be 7. So now the mid value is a of 7. We will compare a of 7 with 57. Again these values are not equal, hence we will move towards the next element of 25. That is, now my new mean will be a of 8. Again the mid is calculated. Now what is the value of mean? 8. What is the value of max? 9. So 8 plus 9 divided by 2, that is mid will be 8. Here mean and mid are occupying the same values, and we can say that the value at this location matches with the key value that we need to search. So our search is successful as 57 is found. If the element would not have found at this location, then the result would be the search is unsuccessful as the key value is not found. Now we will implement the binary search algorithm. The function is written in a C language. So to find an element in an array, what we will need to do is first enter an element into an array. For that purpose, what I have done is I have created an array of size n. I have asked the user how many numbers he wants in an array, then asked the user to enter the values in that array. After that, I ask him which number he wants to search in that array, and I have placed the max value to be n minus 1, because for an array of 10 elements, the maximum value will be from 0 to 9, that is 9 is the maximum value. So first what we will do is we will calculate the value of mid, and the mid will be mean plus max by 2, and this must go on up till and when the value of mean is less than or equal to max. So what was the procedure? First we will compare our mid value with the key value. If they are equal, the number is found at that location. If not, what we will do is we will need to compare the elements and the key value, element of an array and the key value. If the element is less than the key value, then mean will be equals to mid plus 1. If the element is greater than the key value, then max will be equals to min minus 1. If mean is greater than max, the number is absent. What is the efficiency of a binary search? So the best case performance will come when the middle element is equals to the input key that we need to search. What will be the worst case performance? The worst case performance is that the input key is not present into the list. And what is the average case performance? The average case performance is the input key is present but is not into the middle element. To conclude, we can say that binary search algorithm is faster than the linear search algorithm, and its performance increases in comparison to linear search as n grows. Thank you.